Hello guys, good evening. I am James C. Baklaan and our topic for today is alternator. So welcome to Electrical Machines 2. Alternators. So an alternator converts mechanical energy to electrical energy in the form of alternating current. So the picture below is an alternator. It's really hard to identify or see an alternator in our life, but we just don't know we are already let's say riding them, or um, we might not get to see it, but it's actually placed in something we use daily, and those are our cars and motorcycles. So how does it works? Actually, we thought that the battery is the one behind the power system of a motorcycle, but it's the alternator that's behind it. When the car runs, the alternator generates um, power to provide electricity for the electrical system of the motorcycle, and at the same time it charges the battery. Alternator versus generator. So actually an alternator is just a generator, also called as AC generator. What I'm trying to refer with this generator is the generator we once discussed last semester, which is like the DC generator. So let's compare the two. What's the difference between them? So an alternator, um, the field is the ones rotating already and the armature is stationary. Compared to the generator that we know, the armature is the ones rotating to the field, and it only produces AC current. And for the generator, it's both AC and DC. But as we tackle much more further about alternator, we will find out that it also produces DC. But sooner or later, we will discuss that. Now, the alternator don't have commutator mechanism, since the field rotating is mounted to the pulley or to the axle being attached to it, and it's more efficient compared to generator. It's lighter and no polarization needed, and it has large output rating. Now, how does it work? It is the main part of a charging system, as what I've told you a while ago, and it generates electrical power to supply electrical systems of a machine, and at the same time it charges the battery. The picture below is an illustration of an alternator being disassembled. So there are types of alternators, but commonly they have the same parts. For example, the pulley, the rotor, the stator, voltage regulator, rectifier, and the protective gap, and also the housing. So here is an illustration of the wiring of an alternator in a car. Here, the picture below, I mean the bigger image, the alternator. Inside there are the stator field, the rotor field, rectifier, and voltage regulator connected to a battery. So here is the diagram of it. The flow of the power generated goes through the ignition switch or to the battery, but once it goes there, it passes to the voltage regulator, which also came from the rectifier. I will discuss that later on the next slides, what's going on in each part of the alternator. And to specifically discuss that, we will use an alternator of a motorcycle. The picture of a motorcycle there, I encircled it. That's where you can see the alternator. And the second picture is the open one, wherein that's what's inside the alternator. Here is the disassembled part um, of the alternator of the motorcycle. First part is the fan cover and the fan. So the first picture is the fan, wherein it is used to, the first picture is the fan cover, where it is used to cover the whole parts of the alternator, and at the same time, it absorbs the air coming from the outside, of the motorcycle, and it lets the air go through the hole going to the block of the motorcycle. Then the next part is the fan. It's for the cooling system of the motorcycle, and actually it is just a bonus part of the alternator. The next one is the rotor or the magneto. This is the ones rotating, that is going to generate magnetic field through electromagnetic force. Then this one is attached to a pulley, wherein when it's attached to a pulley, once the engine of the motorcycle starts, it starts rotating. Then once it rotates, after it rotates, it cuts the stator coil, wherein the stator coil will generate electricity. Here, stator, it generates electric current as the rotor cuts the stator coil. So this is the stator coil of the alternator of a motorcycle. The next one, rectifier or voltage regulator. And voltage regulator. So what does a rectifier do? A while ago, I said that an alternator only produces AC, but because of this rectifier, it converts alternating current to direct current. So why is that so? Because a motorcycle needs a DC output so that it will run its electrical system. That's why a rectifier is used for the conversion of the power. And voltage regulator. So the voltage regulator controls the amount of power distributed from the alternator to the battery. It's because the power being generated of an alternator increases or decreases. So it's the job of the voltage regulator to regulate certain range of voltage that's being received by the battery. The next one, axle and nut. Axle, it holds the rotor and creates a spinning motion. So this axle, this is where the rotor is mounted. Then this axle is connected to the engine of the motorcycle, wherein when you start the motorcycle, it creates a spinning motion, and since the rotor is connected to it, the rotor spins with the axle. And the next one is the nut, and of course the nut locks the rotor and the fan in place. It serves as a lock. So here are some few formulas involved in solving alternators. Generated EMF per phase design equation. So generated EMF is equals to 2.22 K sub P times K times F times flux per pole times the number of conductors, and so on and so forth. So there are lots of formulas involved in solving alternators, and here are just a few of them. Sooner or later, we will be tackling and discussing and using these formulas when we meet problems involving alternators. Here for the short circuit test on alternators and open circuit test on alternators. So sample problem. What is the speed of a 100 kilowatt, 230 volt, 3-phase, 4-pole and 60 Hz alternator? Here are the choices below. So solution for that, we use the formula N is equals to 120 times frequency over P. And we all have the given 60 Hz and the number of poles is 4. We just plug in the given to the formula 120 times 60 over 4. We should have 1800 RPM, and that's letter C. I mean, yes, that's letter C. For the next problem, a 6-pole 3-phase AC generator has 72 slots and the coil span is 12. What is the pitch factor? Choices The choices are A 0.985, B 0.966, C 0.939, and D 1. So we have the formula for pitch, which is equals to coil span over slots per pole. And for the pitch factor, we have sine quantity 90 degrees times the pitch. So we solve for the pitch. We have the given coil span, and the slots per pole is 72 over 6. Now we plug into the formula 12 over 72 divided 6, that's 12 over 12, which is equals to 1. Now for the pitch factor, which is equals to sine times quantity of 90 degrees times 1, and that's equals to 1. That's letter D. And that's all for today, guys. Thank you for listening. God bless.